Hello everyone. This is Rashid Kibria from Fixed Research, University of Florida. In this demonstration, I want to show another interesting case study analyzed by my RTL-FSMx and FSMx-Ultra. This design named writing, that is basically an example of nested FSM because we have a top FSM and inside that one state is basically another finite state machine. Now, if you look at the RTL description, we have the top FSMs states encoded using this one, and the uh, innermost FSM that has all the states with associated state encoding shown here. This is the RTL description of the FSM. If we look here at the reset condition, the state moves to ideal state or it goes to the next state. So here is basically it is an FSM written using one process model. The top FSM has these states, ideal, address right, data right, and finally the stop acknowledgement. And the inside FSM, that is the innermost FSM, which is driven by this state variable. It has all the states mentioned here. I will try to analyze this using RTL-FSMx and FSMx-Ultra. But before that, I want to synthesize this RTL design using Synopsys design compiler and see what FSM it can actually synthesize. So let's start the synthesis process. I have already developed an TCL script to automatically generate the gate level netlist. It is basically the synthesis script here. I will run the synthesis script using this command. First, I will load change the environment, and then I will just hit this. So it will start running design compiler. You see, it has been already finished. The synthesis process, it is very fast because it is just a single FSM, but it is obviously a nested one. So I have also used here report underscore FSM command to show us the FSM identified by design compiler. Design compiler actually does this via RTL analysis. So if we look here, this is a state vector, and also it is showing us the clock type, the asynchronous reset, the state vector here, which has been used, and also the state encoding. So if we look here, we'll see that only one FSM has been synthesized basically. That means the innermost one, which is driven by sh8 out underscore state, this state variable. But the top FSM was not synthesized because it is basically driving that. So after gate level synthesis, we have already one FSM out of there. Now we just get one, but we cannot get the top one. Now that is the thing here. I will now try to analyze this design using RTL-FSMx and FSMx-Ultra and see what it basically provides us. So I will now go inside our tool directory, and yeah, that's it. I will first try to analyze using RTL-FSMx. I will load the RTL file there. That is here. And then I load the tool. I will hit on the extract control efficiency button, and it will analyze this RTL code and show us the state transition graph extracted from there. If we now try to open up, we see there are basically two FSM extraction report here, 1 and 2, because we have basically described two FSMs at the RTL abstraction, but we do not get both of them after logic synthesis. So it is the top FSM one. It is RTL-FSMx is correctly representing all the states along with their state encodings, with their style, and some other relevant information of this control FSM. We can also view its state transition graph. This one is this one in .png file. This one is the state diagram. The second FSM is here. That is the innermost FSM, which is driven by sh8 out underscore state. this state variable, showing us the state encodings with their order and the style used. We can also view its state transition graph in .png file, and that PNG file is here. So clearly, we have two FSMs described in the RTL abstraction, and we can get successfully extract both of them using RTL-FSMx. Now let's see what FSMx-Ultra basically generates. So I will now go to gate and I will select the flattened netlist version of it because I have just used design compiler to generate a flattened gate level netlist. First, I will load the technology library in .lib format. We can find here inside this one library SAD size 90 nanometer typical library from Synopsys has been used that I am loading. And this .v file is basically required the technology library in .v format because of the ATPG-based analysis performed by FSMx-Ultra. I also add it. Finally, I will add the gate level netlist, which we can find here. But first, I need to clear the previous report here. So I will go there and clear this file. Now we can go inside imports and I will load the flattened netlist. Then I will add the RTL-FSMx generated reports. So I select them and I hit open. And finally, I click on the extract control FSM button. It will start running the tool. So you see it is very fast. The analysis process has been already finished. Now we can find the extracted gate level netlist of the FSM. That means the FSM minimum extraction region. We can find here inside writing underscore report folder. Inside netlist, we will see just a single FSM has been extracted. It makes sense, right? Because this FSM was basically generated by design compiler. It was synthesized to a gate level netlist, but the top FSM, it was pruned out. That's why we are getting just a single one. So if I open up this one, we will see that this sh8 underscore out underscore state range has been extracted, which is basically the synthesis report also says the same, right? So that is the thing here. And so it means that whenever you write an FSM, it does not necessarily mean that you have all the FSMs after logic synthesis. Some of them can be pruned away. There are lots of reasons for it. So, but still, FSMx-Ultra is able to extract successfully the control FSM from the gate level netlist. That is the main point. It does not matter how many times it finds there. For example, in my previous talk, I have actually showed that you may have just one description, one RTL description of an FSM, but you may have multiple FSMs of the same design, right? Because if you do instantiation multiple times. This one is the thing. So there can be mismatches. The number of control FSMs in the described in the RTL abstraction and the number of FSMs you get after logic synthesis at the netlist side. That is the point. But still, RTL-FSMx and FSMx-Ultra, both of them are able to successfully identify the control FSMs and extract the associated state transition graphs perfectly. Thanks for hearing.